Hello, my name is Sean Daly, and today we're going to be talking about intermolecular forces. Intermolecular forces are the forces between two different molecules or atoms, whether they be the same type of atom or molecule or two separate molecules. There are several different types of intermolecular forces. These types include hydrogen bonding, which is what you see in water. That's when a hydrogen atom bonds to the negative part of another atom, usually like an oxygen or a nitrogen or a fluorine. There are things called dipole-dipole, which is just two polar molecules are attracted to each other, positive and negative ends. And then you have something called London dispersion forces. And London dispersion forces are what happens when there's a temporary, when an atom forms a temporary positive and negative end, because all the electrons move over to one side of the atom. So today we're going to be looking at really all three of those. So we have this water right here, and in this water the water molecules are held together by hydrogen bonds, because the hydrogen in one water molecule attaches to the oxygen of another, and so on and so forth, and that is why water is it stays as a liquid as long as it does. So for this experiment as a whole, you're going to need a good bit of water, an empty water bottle, a funnel, canola oil or vegetable oil, some type of oil, and you're going to need food coloring. I'm using red, but you can really use any other color other than yellow, because if you use yellow, typically it blends in with the oil. So what we're going to do first is we're going to add about 2 or 3 drops of food coloring to the water. And when I do that, you'll notice that the food coloring starts to disperse through the water. Well, that's because the food coloring itself is a polar molecule as well. So this is where we get those dipole-dipole forces, because the positive ends of the food coloring have attracted to the negative ends of the water, and vice versa. So now that we have our water good and colored, I'm going to take the funnel and make sure it's good and tight. I have this pan right here in case it spills. And we're going to pour the water into the funnel, or into the water bottle. Okay, so as you see, water just hanging out. So next, I'm going to take the canola oil, and I'm going to pour it into the water bottle. And so what we're going to expect to happen is that the oil is going to sit on top of the water and it's not going to mix. Well, we're also going to notice when they meet, you're going to find some bits of water and oil stuck together. And that's where we're going to see the London dispersion forces, because the oil is going to temporarily form a weak positive and a weak negative end. And so that's going to attract the water. But that doesn't last very long, so it's usually really hard to see. So I'm going to pour some oil in there. And you see it's mixing up as I pour. But once that settles down and sits for a minute, you see a clear distinction right here. And you can still see some mixture, but the most of the oil has moved up here. And that's partly because water is denser than oil. But you can see there's some bits of water and oil that are still mixed together. But again, the oil hasn't dissolved in the water. So, and that's due to the fact that oil is a nonpolar molecule. So it doesn't have a positive and negative end. And water is a polar molecule. And so they're both separated, but you, again, can see a little bit of how they've mixed together. And so typically this amount of oil will probably never dissolve in this water. Like the forces won't, the London dispersion forces won't occur enough and last long enough for it to completely dissolve. However, you can still mix these two if you take the bottle and shake it really fast like this. And that ends up with a weird orangish, kind of shiny, because you can still see the oil molecules in there. So, and when you let this sit for a minute, you'll start to see the water collecting down here and the oil collecting up here. So, in conclusion, intermolecular forces are everywhere. They're used in cooking, in crafts, from here all the way around the world. They're what make liquids and solids possible. They're extremely important to nature and biology, and they're key to chemistry. So thank you for watching this video, and have a nice day. Bye.